Hello guys, a very happy morning to everyone of you. Guys, now we are just seeing about the industrial engineering. Okay, so in the previous class I think so I have covered the first chapter and second chapter. I have for inventory control and break-even analysis. Suppose if we haven't still seen about that kind of things, means I request you to just go and watch and have a good idea about that. Okay, before going to that, we will have just 2 minutes of revision. So that is simple thing. Inventory model, deterministic model, probabilistic model. Okay, so this thing, everything is Wilson, Harrison models and everything is it. So total variable cost equal to total cost equal to inventory cost plus of total variable cost. Okay, you can see this one how the graph will be there. So number of orders. So demand divided by which one? Demand divided by quantity. How much quantity of this order? Okay, number of demand divided by quantity into ordering cost. Okay, total ordering cost C naught. Okay, suppose holding cost means Q divided by 2, that's it. Okay, into CC. It means we are just taking Q average into CC. Okay, total variable cost is total ordering cost plus of carry cost. Okay, D divided by Q C naught plus Q divided by 2 of CC. Okay, so next one, total item cost. This is total cost. Okay, whenever you just take it as minimum, you just convert the cost as a minimum equal to that time what will come economic order content Q not equal to 2 take C dot of CC. Okay, just a simple thing. So you can see this is a minimum. So whenever you just go apply this video in which one total and ordering cost and holding cost, you will come get the same answer while you just adding the total variable cost is root of 2d C naught of CC. Okay, okay, so you can see the total minimum cost is this one. Okay, 2d C naught of CC and item cost. So next one you can see ordering cost is everything, holding cost is something. So you can see generally the ordering cost will be following rectangular hyperbola. Okay, ordering cost will be following rectangular hyperbola, but the holding cost will just go in a line. Okay, it will be different. Okay, so you can see this one Q dash. Okay, holding cost and ordering cost is everything, and Q it means Q star. Okay, so Q star equal to economic order quantity, this one. Okay, so this is ordering cost, this is total variable cost, this is total variable cost. Total variable cost I think so you would have known. So this service ordering cost is higher, holding cost lesser. This service holding cost is lesser and ordering cost is lesser. Okay, that's the simple thing. So this is economic order quantity. So one follows rectangular hyperbola, but other follows the which one? Just the slope, which is just right. Okay, so observation of the graph you can see. This is normal thing only. So you can see total variable cost normal with respect to total variable cost minimum is so. So this one sensitivity is equal to 1 by 2 Q by Q star plus Q star divided by Q. Okay, this is the main formula. Okay, so next one, inventory model with the shortage. Okay, you can see this inventory model with the shortage and back order. Sometimes the shortage and back order gives us an extra profit. Okay, so what is the thing? This is the graph. Okay, you can see IM, this one is the shortage, after this one total is Q divided by, it means Q divided by the slope is entirely T1 and T2. Okay, just to make it small. Okay, IM of T1 of D. Okay, D equal to IM of T1 same divided equal to shortage of T2. Okay, both of the things. So each and every curve, it means the ratio will be same. Okay, you can see shortage equal to demand into T2. Okay, I think so you can understand. So whenever is multiply, the shortage will come. Okay, so total cost equal to item cost plus item cost, ordering cost plus holding cost plus shortage cost. Okay, because of shortage also we might have any kind of benefits. Okay, so we can, this is anything. Okay, so first we need to find the shortage cost and the maximum inventory. Each and everything we have to just find. Okay, so you can see this one quantity equal to demand plus of time. Okay, so S equal to D of T2 is everything. Okay, so you can see this is holding cost. You can see Q average into CC. Okay, this and this. Okay, divided by total time CC into IM T1 divided by 2 of T. Okay, shortage cost equal to average shortage cost, the entire thing about this. Okay, 0 into T1 plus 1 by to T2 into S divided by T, okay, into the total is short cost, okay. While you are just getting, we'll just get the answer, okay. So total variable cost is this entire thing, okay. I think so we are getting the point. So it means whenever you just T1 of T, T2 of T, we just will get the certain answer, okay. This thing. So T1 of the entire time, okay. So you can see this one. T1 equal to IM of T, okay. Put here and we'll calculate that. Okay? You can see this one. Which value is low. This is the basic ratio. You just can put here and we'll get the answer. So total variable cost is this one only, okay. So next total. So while you just differentiate, what will come is the shortage cost, okay. This is the shortage cost for minimum, okay. Number of shortage per meter for minimum cost, okay. So Q by T CC carry cost divided by carry cost plus of shortage cost. Yes, okay. CC divided by CC plus of CS, okay. So Q star equal to 2 root of 2D C naught of CC bracket of CC plus CS divided by CS, okay. This is a Q dash, okay. So whenever you just add the holding cost and holding cost, it means in this holding cost and the shortage cost will be there add the same matrix, okay. So total minimum variable cost is this entire thing, okay. Simple thing only, guys, okay. So you can see without shortage equal to Q dash equal to 2D C naught by 2 CC, but here Q dash equal to 2D C dot of CC of CS plus CS of CS plus CC divided by C of S, okay, shortage cost, okay. So you can see shortage for minimum is Q CC divided by CC plus CS, okay. You can see this is inverse, so that's it, okay. CC will be CS will that's it. So total because it has order cost equal to holding cost, but here order cost equal to holding cost plus your shortage cost, okay. These are all the points. So you can see 2D C naught of CC. The entire thing just make it inverse, that's it, okay. So post production and consumption, I think so. I would have explained. So you can see this total variable cost equal to setup cost plus holding cost, okay. Setup cost, it means a setup cost and holding cost in the same thing, okay. So let us go for the second chapter. So this thing is fixed cost. So you can see total cost equal to fixed cost plus total variable cost, okay. This is it. And this is the slope, it means, okay. Perfect. And now we just go, this is okay, and this concept. So you can see this is total cost and the total sales, okay. We need to just have a relation, okay. So you can see this one. So total cost equal to fixed cost plus of variable cost equal to total sale quantity into selling price. Well, we can just get the Q, it means economic order quantity, basic economic order quantity, F divided by S minus of V, okay. This is it thing. It is such a quantity which is neither earning profit nor loss, okay. Simple thing. So you can see next one, angle of incidence means the total sales and total cost. This is the angle of incidence, okay. Tan alpha equal to this one, tan alpha equal to total sales, tan beta equal to V total cost, okay. Slope of variable cost, okay. That's a simple thing. So theta equal to alpha minus V. So tan theta equal to tan alpha minus of beta equal to this entire formula, tan alpha minus tan beta divided by 1 plus of tan alpha tan beta, okay. So you can see, just to make sure place here and we'll get the triangle of incidence, okay. So that's why you can see early break-even point is reasonable. Early break-even point can be achieved by achieving the increasing sales price, okay. Decreasing or reducing the fixed cost, okay. Next one, decreasing or reducing the variable cost, okay. So break even this one equal to S into F. So you can see break even point, it means sales. If we suppose break even point is 0 into sales, okay. That's it. For achieving zero profit, okay. Simple. So next one, margin of safety is Q actual minus of Q of break even point. Okay, margin of safety equal to, it means margin of safety is Q actual minus of Q of break even point. Okay, the reason when you just in terms of money means just multiply the selling price. Okay, that's it. So margin of safety in percentage is Q actual minus Q break even point divided by Q actual. That's it. Okay, so now we can just start the third one. Okay, third chapter. So this one is called project management or the PERT or CPM. Okay. So you can see this one. It is a task which has definite beginning and definite ending with interrelated activities which consumes time and resource. Okay. Important things for a project steps to planning, scheduling, and control. Okay. So first one is planning. We should plan. Second one is scheduling, and third one is control. Okay. All of the three things must be there for our project management. Okay. So this is what about. You can see network diagram. It is a graphical representation of project which shows all interrelated activities. Okay. Next one, activity. It is a physically identifiable part of project. You can see activity is a physically identifiable part. Okay. Physically identifiable part of a project. Okay. So next one, you can see activity analysis. So you can see starting event, and this is one is ending event. Okay. Start event, this is end event. Okay. Activity will be represented here. Okay. This is tail head. You can see tail head. This is head event. Okay. Tail event and head event. Okay. There are two things. This is activity unknown means in the activity we just write this. This 6 represent how much time it takes to took. Okay. You can see this starting point, this ending point. So from starting to ending, how much time it has just took this kind of this thing. Okay. So you can see activity is a physical identifiable part of project. So it means identify part means it just tells how much time we have just around the consumed and how much we are able to do the work, like that it just tells us. Okay. A simple thing guys, construction, it means constructing rain harvesting bit. We need sand, steel and cement. Okay. Bringing sand, steel and cement are independent activities. Okay. But at the end thing we need to just place it same. For example, I need sand, steel and cement. Okay. Now I just got the cement. Can I start the project? No. I just got the sand. Can I start the project? No. I get the steel. Can I start the project? No. So for example, it means I just told to a person, so he just goes and get the sand first. Okay. It took him just 2 hours. So after that what I just asked the other person to get steel. It took him 6 hours. I just asked the other person to go and buy cement. It took him 10 hours. So at the 10th hour only I'm just starting the each and everything. Okay. So you can see dummy event. Okay. So this is at the 10th hour I'm just starting the activity. Okay. And after that I'm just continuing. Okay. For next 2 days I'm working, and after 2 days work I just consider the demonstration. Okay, that's it. Simple thing only guys, no need to confuse. So you can see dummy activities is used to represent logical sequence in a project. It neither consumes time, it doesn't consume time, and nor resource, it doesn't consume resource. It is shown in the form of data line. Okay, data line. Okay, that's it. So you can see note, while drawing network diagram, use minimum dynamic activity as definitely. So the dummy activity must be minimum. Okay. Okay. Dummy activity must be minimum, and use of dummy activity must be minimum. So next one, predecessor means previous activity, successor means next activity. This also one of the important. Okay. Predecessor, previous activity, previous activity. Successor means next day activity. Okay. This is the most important that you just want to keep in mind. Okay. So you can see simple thing guys. Suppose A, B. So you can see here start of A. So here what will be the end of A. End of A will end and begin of start of B will occur. Okay, I think so. Got about it. One second. So you can see next one will be the burst event. So from first event is a lot of other event will occur. Okay, you can see when so many activities are concerning single event, it is called as burst event. Okay, I think so. Got the point. So next one is a merge event. Okay, so you can see merge event when so many activities are converging at a single event, it's called as merge event. Okay, rules for drawing network diagram. A network must have one start and one endpoint. Okay, that's definitely. Yeah, network diagram must have one start and as well as one ending point. Okay, so it means like this definitely activity doesn't occur. You can see like this only generally like this from one to different point only will occur. From here like this it won't definitely occur. Okay, this thing you have to keep in mind. Okay, and you can see unique start and unique end. So at the end only one end should be. Okay, so no two activities have same beginning and same ending. Okay, we should not have like this. Okay, no two activities have same beginning and same end. Okay, two activities must have same beginning and the same end. Okay, so like this it not be, but like this it can be. Okay, it can start from one thing. Okay, and after the dummy event it can just reach like this. Okay, I think so you got the point. So you can see activity C only occurs when A ends. Okay, so you can see A starts and A ends here, so then activity C can start. Okay, activity D can start only end. Activity can start only D ends. Okay, so you can see both A and B ends only activity C starts. Okay, activity E starts when both and A, so put a dummy even. Okay, that's simple thing only, guys. So next one you can see C should start only when A is complete. Okay, so you can see only when A, this one is B. Okay, this one is A. Okay, B. So you can see what I just want. C should start only A is completed. So just put here, that's it. Here dummy one, that's it. Okay, you just put here or here, anything is advantage possible. Okay, so why it puts it means you can see here the end of both A and B occurs. Okay, here end of A, here start of C, here end of C occurs, and our process just continues. Okay, so in case we just put here like this, upper arrow means you can see dotted line of upper arrow, what will be that here end of A is there. Okay, as well as you can see here A, end of B, but B go and ends here. Okay, end of A as well as end of B will occur. So in this process definitely here the C won't start. Okay, so the arrows also so much important. Okay, so you can see this one, C starts only after the A. Okay, so this is here, and D only after AB. Okay, this is B. So you can see this is C, and let us like this. Okay, now D starts here, end of A and B. Okay, oh see, I just use the maximum number of dummy event here. Okay, 2 dummy event we just use, so we need only 1 dummy event, minimum number of dummy event. So we can also write like this, this is A, this is B, this is C. just to make the dummy one like this. So you can see here end of A and B. Here D starts. Okay, that's it. Simple thing. So, okay. We can just see the next question. See only after A. Okay, it means you can see this is A, this is B. So you can see C only after D. Okay, so C only starts C like this. Okay. So next one, E only after D. Okay. This end D1. So this is E. Okay. This is end of B. Okay. So you can see D only after A and B. Suppose if I just join these two, definitely the C can't be there. So put like this D. Okay. Perfect. Okay. So next one, looping is not allowed. Definitely looping is not allowed. Okay. This is also one of the most other important thing that you just want to keep in your mind. Looping is also not allowed. So like this. Okay. So next one, you can see disconnected event is also not allowed. You can see now 1 2 goes and each and everything just ends, but you can see here 6 is so much disconnected, where it will go and join. So everything, every event must have conclusion. Okay. So you can see this conclusion must be there. Okay. And redundancy must be avoided. Okay. So you can see dummy event takes sometimes it is so don't use the dummy event unnecessarily. It means so process 2 to 4 will occur, but instead of going that you know you don't need to put this kind of 3 here. Okay, simple thing. Network should be drawn strictly as per the given information. Yes, most important thing. Network should be drawn based on given information. Okay, no extra. Okay, so you can just see this one. Okay, just a simple thing how you can just start a diagram. So you can see 1 2 and everything is done. So event is this is a normal thing. This one is A, this one is B. Okay, so you can see after A only C comes. Okay, end of A, here C will come, here end of B, E will come. Okay, you can see both D will also come here. Okay, so here also both like this. F. So here D and E. Okay, while D and E ends, okay, D and E ends, we get this letter F. Okay, so here F and G. Okay. So let us suppose like this. So this is end of E. Okay, let us make like this. This is end of D and dummy event. Okay, this is what will be the D and E ends means it is G. Okay, this is beginning of G. Okay, so okay, as you say, you're getting the point. This is end of E and D. Okay, here it's beginning of G. Okay, just put on here the end of F. Just put here this is end of G. Put a dummy one. Put here H. That's it. Okay. C. One of the mistake is where is this C? C's final product we just haven't mentioned. Okay. This also is a good thing. Okay, just a simple thing because you can see here A because but guys this also same. Okay, but why I just mentioned this kind of dummy means suppose D takes 2 days to finish the work, but E takes 5 days to finish the work. So we need to just place the dummy over here. Okay, just a simple thing. So if it takes 2 days and he also takes 2 days, means it will just okay, 2 days, 2 days, simple. Okay, A, B, and after that C, D, and E, F, or you can see D, E intersect G. Okay, after end of this one, so C just connects it. So you can see event numbering is fuel full currents rule. Okay, tail event should have less than the head event. Okay, so let us try this one. So activity places are 1, 2. Okay, A, B. After end of A, B, C, D comes. Okay, so right, so end of this one is A, B, just put here and one dot. Okay, here end of B. Okay, here end of A and B. So from here C, from here D is there. Okay, so B, let's see this one is C. D and E goes to, you can see D and E. Suppose if it has same time as D and E, okay, goes to D and E goes to F. So next one C and F. Okay, like this. C and F goes to G. Okay, next one D and E. Okay, D and E leads to H. So next G and H goes to I. That's it. Okay, see. Okay, so why we did this one means because looping is not allowed. Okay, okay, so I can just go to the next question. This will be the last question. Okay, okay, A, B. So oh, so you can see from here C starts. So A, B, T, okay, D. This one E. This one is B. This one is E. So here F. Okay, F. So you can see E and F, G, and D and F. Okay. So put here and put here dummy event. That's it. Dummy event. Okay. So this would be end of this one is this H. That's it. Okay. So 2 dummy events will be there. 1, 2, 3, 4. Oh, 3 dummy events. Okay. Oh, okay. It's not a bigger case. Okay. It means yes. Here are the dummy. Here are the dummy. Okay. So 4 dummy events will be there. So now we will just see the other thing. Okay. So you can see time analysis. All times are known within certain deterministic. Okay, all times are known. Okay, we know all times are known. Okay, deterministic. Okay. So you can see I, J. This one is given activity and this one is time. Okay, how much time it has took. So T is a normal time to do work. Okay. So T is normal time to do the work or activity. Okay, so you can see this one A, B, C. So you can see it means EI, it means you can see L is start of B. Okay, see guys, suppose if I'm just asking you to do a certain work in 5 days, so but actually for that I just gave a duration of 5 days to do work. It means for doing that work you just need only 2 days. So you can start at the beginning of the first day, 0th day, or you can just start at the 4th day, and 4th and 5th you can work and finish the work, or first day and second day you can start and finish the work. Okay, it depends on your thing. Okay, you can see EI is earliest start of B and LI is late start of, it is this one, early start of B, and LI is late finish of, finish time of A. Okay, A. Okay, EJ is earliest start of, EJ earliest start of C, and LJ is late finish of B. Okay, late finish of B. Okay, simple thing was there. I'll just explain you with the diagram. So you can see this is the entire thing, and 1, 2. Okay, 1, this one is 2, this one is 3. So 1, this one is 2, this one is 3. So for this one, how much 50 days he just took? So this is 0 3. For the third one, this is also 15 days he just took. Okay, for for 2 to 5, it means 2 to 5. Okay, for 2 to 3, it just it means he just took how much days? 3 days. And for 2 to 5, he just took 5 days. Okay, okay. So next one you can see 3 to 4. So this is the third event, fourth event is starting. Okay, fourth event. So fourth event is literally 8 days. Okay, so next one 3 to 6. Okay, sixth event. So sixth event takes 12 days. Next one 4 to 5. This one 4 to 5 is 1 days. Okay, next one 4 to 6. This one 14 days. Next one 5 to 6. Okay, 5 to 6, 3 days. Next one 6 to from here. Okay, sorry. Okay, 3 days. 6 to 7, 14 days. Okay, so now I'll just explain you. So you can see here 0 by 0 will be. Okay, going to, so for finishing of this thing 15 days must be there. For finishing of this event, how much days is required? You can see it means the maximum event. Okay, maximum thing only we need to consider. So for finishing this one, you can see 15 days, and you can see this one so much 15, so 18 days we will take. Okay, so 18 plus 18, 26. This one 27. So 20 days, 27 days, and 18 plus 12, 30. Okay, so 18 plus 8, 26. 36. This one 40. So here 40 days will be there. Okay, so 40 plus this one 14, so 54. So while we just going backward, you can see backward 54 days, and this one 40 days, and 40 days in this 40, just minus of 3 days, so you can see 37. So we can begin this work at the 27th day or 37th day also. Okay, so while you just go backward from 37 to this one, so here it will be 40 minus 14 here 26, here also 26 will be, okay. So this thing, okay, you can definitely do it, okay. This one you can see 40 here will be, and here minus of 12, and this thing. It means how to say means while we are just traveling like this we take maximum, and while tracking like this we travel minimum. It means forward travel maximum, backward travel minimum, okay. So the minimum thing we need to just take, okay. Okay, this one is 15 and this one will be 18, okay, that's it. Okay, I'll just explain you once again. You can see in backward pass or reverse pass subtract minimum, it means select minimum. In forward pass we request to add the maximum one, okay. I think you can understand. So you can see for starting activities C and B, A and B should finish, okay. So one merge event should one, we need to select only maximum, okay. So you can see determination, it means determination of floats and slugs, okay. Floats, total float, okay, means total time duration is available, okay. For the total duration, how we can just find the entire thing? You can say total duration equal to this one. So total float equal to LJ, okay. This one is a late start of which one? The previous thing, late start minus of early start of this one minus of the entire time, okay. It means it is a maximum amount of time by which an activity can be delayed from earliest without delaying the further, okay. Total float can affect all activities definitely. So next one is free float, okay. So you can see EA, LI, EJ, LJ, okay. Free float is independent of the late finish time, so only it means depends on the start. So free float is this one, okay. So you can see the time by which completion of one activity, completion of an activity can be delayed without affecting the start. It means succeeding activity called free float, okay. Completion of activity can be delayed without affecting the start of succeeding activity called free float, okay. So you can see free float can affect only the predecessor. Free float can affect only the predecessor activity, okay, that's it, okay. So next one you can see independent float. Independent float means you can see it means predecessor and the second both are not. It is a minimum available time over the required activity duration. So you can see independent float only affects a particular concerning activity, okay, that's it. So total float greater than free float greater than independent float, okay. This is the time duration, that's it. Okay, so tail event slack equal to L, it means Li of EA, okay, tail I minus of EA. Head event slack equal to LJ minus of EJ, okay, that's it, simple thing. So float is related to activity where slack is related to event, okay, that's it. So head event, free float, everything is given, okay. This is a basic thing, it means you have to just keep in your mind, okay. It means EI, LI, EJ, LJ, okay. So what is the total float? So this is the total float, okay. Total float. So next one, it means this one Li and EJ is a independent float, okay. So next one EJ and EA is a free float. So free float equal to this free float equal total float, which one total float minus the head events like, okay, that's it. So free float is so much easier to just find, okay. So you can see independent float is free float minus the tail event, that's it. This free float minus the this event, okay. So it means for finding the free float you can see total float minus of this thing, okay, head events like, okay, that's it. Simple thing only, at least we can understand. So guys, and tomorrow I'll just complete this entire chapter, okay. Okay guys, let me see you in the next one. You can take it. Bye bye. Have a good day.